Today we're going to learn how to prove if an argument is valid by using the truth table. So to do this, what you would need to do is put all the arguments in the truth table, and if all the critical rows have a true conclusion, then the argument is valid. And remember, a critical row in a truth table is one in which each premise is true. So here's the argument that we're going to prove as an example. So 1, P implies R. 2, Q imply R. Therefore, our conclusion is P or Q imply R. So let's make the truth table to try and prove this. So our number of columns in the truth table. This is going to be 7, and how I got this number was I counted our arguments, P, R, Q, so that's 3. And now we've count our premises. So there's 2 premises. P implies R and Q implies R, so that's 5 total with those 2 premises added to the 3 arguments. And finally, we're going to look at this conclusion. Now this inside the parentheses has to be its separate column, so that's 6. And finally, the whole argument, or the whole conclusion is 1, so that's 7. Now our number of rows is going to be 9, and I got this number because the total number of rows in a truth table is going to be 2 to the n, where n is the number of variables or arguments. And then, so that's going to be 8, since we have 3, 1, 2, 3, and I added 1 to make it 9, so we can add a label at the top. So let's start filling out our truth table. So first, we'll make the labels at the top. We have our variables, P, Q, R. Now we have our premise, P implies R, and Q implies R, sorry. And then inside the parentheses, we had P or Q, and our final conclusion, P or Q implies R. Okay, so let's fill this out. So let's do the variable rows first, since those are easy to remember. Remember the first is T, 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 4 T's, F, 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 F. Let's see if I can get that row on the same page. Okay. Now this one is T, 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 F, F, T, T, F, F. Now we have T, F, T, F, T, F, T, F. And this is just a technique you learn when you learn how to do truth tables. So let's fill out the table for this first premise. P implies R. So we look true implies true. And this is going to be true. Now we have true implies false, which is false. True implies true, which is true. True implies false, which is false. False implies true, which is true. False implies false, which is true. False implies true, which is true. And false implies false, which is true. And if this is confusing, then you may want to review the rules for the conditional statements where the true implies true. So now we'll do the second premise, Q implies R. So we look at Q and we look at R. So true implies true, which is true. We have true implies false, which is false. We have false implies true, which is true. Now we have false implies false, which is also true. We have true implies true, which is true. We have true implies false, which is false. We have false implies true, which is true. And finally, we have false implies false, which is true. Okay, so now let's look at P or Q. So P or Q. True or true is true. True or false, true. True. False or true is true. False or true is true. False or false is false. And false or false is false. And now we finally have the column for our conclusion. So now we use this column and R to decide. So here we'll have true implies true, which is true. This one will be false because it's true implies false, which is false. Next we have true implies true, which is true. Now we have true implies false, which is false. Now we have true implies true, which is true. We have true implies false, which is false. We have false implies true, which is true. And we have false implies false, which is true. Okay, so our table is filled out. And now what we're going to do is look at each critical row and see if the conclusion is true. So let's highlight the critical rows. And remember, a critical row is one in which the premise is all true. So this row here is going to be critical since these premises are both true. This row also is critical. This row will be critical. And both of these rows are going to be critical since the premise is true. Now, if an argument is valid, each critical row will have a true conclusion. So if we look at each row we've highlighted, the conclusion, which is the last column here, each one is true, meaning the argument is valid. And that's how you use a truth table to prove that an argument is valid. Thank you.